Welcome back to Solving Equations and Inequalities with Rational Numbers Part 2. Today we're going to focus on equations and inequalities with multiplication and division in them with rational numbers. Pay really close attention in this video because there's a kind of a tricky part to it, but I'm going to explain it very well, so hopefully it won't be tricky for you when you are done. Well, let's get started. So in this first example, we're going to review some of the basic steps of solving again. In the last video, we talked about setting it up like a balance, that both sides of the equal sign, there is a clear balance. And what I do to one side of the equation, I must do to the other side to keep that balance. So in the last unit, we talked about how this represents multiplication. And to undo multiplication, we need to divide. And I know some of you may be thinking, oh, divide by positive 6. But let's think about that. If I have negative 6 divided by a positive 6, that gives me a negative 1. That doesn't leave z alone. So we're actually going to divide it by a negative 6. Both sides by a negative 6. Negative 6 divided by negative 6 makes 1. So that means I have 1z. And then 42 divided by a negative 6 will give me a negative 7 because a positive divided by a negative makes a negative. And so this will be our answer. So we can go back and check. Negative 6 times negative 7, does that equal positive 42? Yes, it does. Let's look at this next example. So we have negative 12 equals y divided by negative 4. So first thing, once again, we're going to draw that balance. So I said that this is y divided by negative 4 because remember, every fraction is just a division problem. So if I am dividing, we are going to need to multiply by negative 4 on both sides. So these negative 4s are going to cancel out. We're going to be left with y on this side. And then negative 12 times negative 4 will give me a positive 48. So now we're going to check our answer. So 48 divided by negative 4. If I work that out, I'll get negative 12, and that is our answer. So we worked it correctly. So positive 48 is our answer. Okay, we are on the last equations example. So let's start by once again drawing our balance. So we're splitting our sides. We talked about how when we see a number and a variable right beside each other, they are multiplying. So to undo the multiplication, we're going to divide. So I have divide by 9 and 2/10, and then we're also going to divide by 9 and 2/10 on this side. So 9 and 2/10 divided by 9 and 2/10 makes 1, so I have 1x equals, and then I can tell that if I have a negative divided by a positive, my answer should be negative. So I'm going to go ahead and drop my negative down. But then I'm going to come over here and actually do the division. And I also remember that to divide, I need to move my decimals out. So now I have, this is 92, and we have 2,806. So 92 will not go into 2, it won't go into 28. So it will go into 280 though, 3 times, because 9 times 3 is 27. So that would be a good guess. So 2 times 3 is 6, and then 9 times 3 is 27. So we are left with 4. Bring down your 6. 92 cannot go into 46, so we need to add a 0 up here. Now bring a decimal, bring that decimal up, and add a 0 and drop it down. So now I'm trying to look, how many times will 92 go into 460? So I'm going to say it's probably about 5 times, because 9 times 5 is 45. 5 times 2 is 10, carry that 1. 9 times 5 is 45, plus that 1 is 46. And I would have 0 left over. So my answer would be negative 30 and 5/10. Now we are moving on to inequalities. So I'm hoping you are all paying really close attention. You can see Mrs. Gillum is screaming on your screen. It must be really important. So to solve inequalities, you're going to follow the same steps as solving equations, but you must flip the inequality sign whenever you are multiplying by a negative or dividing by a negative. Notice I put the little flip-flops to hopefully remind you that if it flips signs, like from a positive to a negative, it's going to flop the inequality sign.
Wait, what do you mean we flip the sign?
I'm sure some of you are wondering why this works, so let's try it with some basic numbers. I can say that 5 is greater than 2. We know this is true. But what happens if I multiply them both by -3 to keep it balanced? Because what I do to one side, I have to do the other. Well, this now is -15, and this becomes -6. And if I put the greater than sign there, it is no longer a true statement. So this is why we flip the symbol to make it a true statement. Because -15 is less than -6. And the reason this happens is, remember we talked about how the multiplying by negative flips it to the other side of the number line. Well, 2 was smaller, so when it flipped, it didn't flip as far away from 0 as the 5 did. And the same thing happens if I would divide. So let's go back to 5 is greater than 2. If I divide this by -1 and divide this side by -1, then I have -5 is greater than -2, which we know is not true. So that's why, once again, we have to flip and say -5 is less than -2, because dividing by a negative flips us to the other side of the number line. Now let's look at an example of actually solving this. So once again, let's start with making our balance. This says a divided by -5 is greater than or equal to 15. So we know if this division, we're going to multiply by -5 on both sides. These are going to cancel out. We are going to be left with a, and then 15 times -5 is going to be -75. But we multiplied by a negative, so my sign is going to flip. Notice it flipped a lot when I multiplied by a -5 to all the way to a -75. So a way to think about this is go ahead and let's graph our answer. So we're going to put -75, -74, -76. This is going to be a closed circle because it says equal to. And we're going to be going to the smaller side because it says anything less than. So here's another reason this happens, is because when I go and plug in, remember, these are our solutions are on this side. So if I plug in a solution, let's do -80. So -80 over -5 is greater than or equal to 15. So if I do that, I would get 16. 16 is greater than or equal to 15. So our final answer is A is less than or equal to -75 is correct, because the further you get into the negatives, the greater the negative is, but when you divide it by that -5, it's going to make it a bigger positive number. Okay, let's do another example. Let's draw our line to keep it balanced. We've talked about that this means multiplication, so we are actually going to divide by -2 4/10. Notice I'm not changing it to a positive. You are dividing by the -2 4/10. Okay, -2 4/10 divided by -2 4/10 makes a 1. So I have 1x left. And then I'm actually going to come down here and divide this. So I'm going to go ahead up here, though, and move my decimal so I can divide by whole. So I need to also move that decimal. So now I have 24, and 732. So 24 cannot go into 7, but it can go into 73. It can go in there 3 times. 3 times 4 is 12. 3 times 2 is 6, plus that 1 is 7. So I have 1 left over. Bring down the 2. 24 cannot go into 12, so we're going to put a 0 placeholder. Bring a decimal, bring it up, add a 0, bring it down. 24 will go into 120, 5 times. 5 times 4 is going to give me 20. 5 times 2 is 10, plus the 2 is 12, so we have 120. So then I have a negative divided by negative makes a positive. So So notice, this time it switched all the way from a negative to a positive because I'm dividing a negative by a negative. So when that happens, it's going to switch the sign. Okay, we are on the last problem. Let's draw our balance. So this is multiplication, so we're going to divide because we're always going to do the opposite to undo. So we're going to divide by negative 2.5 because it is the one with the x. It's not based on which one is on the left side. It's based on which one is with the variable. So we're going to divide this side by negative 2.5 as well. Negative 2.5 and negative 2.5 make 1, so I have 1x here. But then I need to divide these two mixed numbers. So first thing we have to do is make them improper. 6 times 4 is 24, plus that 1 is 25. So I have 25 fourths. 2 times 2 is 4, plus the 1 is 5. So I have divided by 5 halves. But another way, instead of dividing, which you could actually divide this one straight across because they're nice numbers, you can divide this one straight across. 25 divided by 5 is 5. 4 divided by 2 is 2, so that would give you 2.5. Or you can multiply by the reciprocal and do 25 fourths times 2 fifths, which will give you 50 20ths, which will also give you 2.5. But then I need to look, I have a positive divided by a negative, so my answer is going to be a negative 2.5. And then my sign is going to flip because I divided by a negative. That's only when this bottom number is dividing by a negative. You are officially done with your notes for today. We will be going back over this again in class, so please come with questions ready to ask.